this is a crude exercise, but I'm just going to ask you to go along and try your best. Okay, so try and find the area of this between 2 and 5 here of this function here, 1 over x. So use Riemann sum to find out this area here. Okay, so press pause and have a go. Okay, so our normal routine here is to is to is to is to get this whole length here from here to here. So get B, take away A. So that would then give us this whole length here. Divide it into n number of strips. Okay, divide it into n number of strips. So delta x here would be 3 over n. So our normal routine here is that the x coordinate here would be here, would be 2 plus this delta x here. So this here is delta x. Remember, delta x is 3 over n. Okay, so the area of this this rectangle here is this is the rectangle here. Okay, so the area of this rectangle here would be this height. So that would be this bit here. That's the height of the rectangle here, and then we times it with the delta x, the width of this strip here. So that will then give us, so this whole bit here will be the area of our first rectangle, and then the area of our second rectangle would be this. So times 2 here, it gets multiplied to this top, giving you a 6, and so on. So the height here, the height of this second rectangle here, the height of this second rectangle here would be this times this, and then dot 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 dot, and then sum up all the strips. So the area of this whole thing here is approximately this whole thing here, and then we would follow our normal routine. So a neat way of writing this whole thing here would be this. Okay, and then our normal routine would be to know that this is a constant. We can take it out, so that will then take us to this. Okay, and remember the original function was 1 over x. So really we've got to put this whole thing here into the x here. But then we're going to have 1 divided by this whole thing here. So we're going to have 1 divided by this whole thing here. So we're going to have to tidy this thing up. It merges into one fraction, and then we can do 1 divided by this in a neat way. Okay, so we know we've got to put it into here, but at the moment we've got a fraction within a fraction, so we need to tidy this bit up. So concentrate on tidying this up first. So that would then turn this into a fraction, and then times top and bottom here by n. So the two denominators here will be the same. So that will then take you to here. Now that the two denominators are the same, we can merge the two together, giving you this. Okay, now we've got one fraction. So it's 1 divided by that. So it's 1. Remember, our original function was 1 over x. So we now that this is one fraction, we can put it into here. So it becomes 1 divided by that whole thing here. Okay, so now we can visualize it as 1 divided by. So that's this divided by, and then this whole number here, Okay, and then dividing is the same as timesing the reciprocal, so that will then take us to here, blah blah blah. It then becomes this. Okay, now hopefully you cannot go beyond this. Hopefully this is a bit that you're stuck, because now you've got to sum up this whole thing here. You see, in the past when we were trying to work out something like f of x equals x, let's say 3x squared, say the area underneath the quadratic here. Let's just say in the past we could work this out, because we would isolate the x squared here. So we would be able to jump to something like this, and then from here we would be able to use this formula here. But then when you get to this stage here, there's no way of isolating the k. You see, in the past we could isolate the k squared, and then we would jump to this formula here. and then use this formula. But now when it comes to this stage here, the k, there's no way of isolating the k. So hopefully this is a bit where hopefully you cannot go beyond this. Okay, hopefully this is a bit where you got stuck. You see, in the past, we could work out, let's say, the area underneath f of x equals x to the power of 3, because we would somehow isolate the k to the power of 3, and then once we've isolated k to the power of 3, we would then jump to this formula here. In the past, we could work out f of x equals, let's say, 3x squared plus 4, say. We would somehow isolate this x squared. We would somehow isolate this k squared and then jump to this. But then here, we have no way of isolating this k. Even if we could isolate this k here, even if we could isolate 1 over k here, we've got no formula. Let's say k equals 1 here. We've got no formula that we can jump to. You see, once we've got, if we get to k squared, once we've isolated the k squared, we can jump to this formula. Once we've isolated the k to the power 3, we can jump to this formula. We've got nothing to jump to here. Even if we can isolate this 1 over k, with our current knowledge, we have no way of, we've got no formula in order to be able to work out the summation of this. So this is a bit where we would get stuck. Luckily, we have a theorem that will bypass this problem. So now luckily there's a theorem that will allow us to bypass this problem, and we will look at this theorem another time. Okay.